Two right circular cones with vertices facing down as shown in the figure below contain the same amount of liquid. The radii of the tops of the liquid surfaces are 3 cm and 6 cm. Into each cone is dropped a spherical marble of radius 1 cm, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid level in the narrow cone to the rise of the liquid level in the wide cone? So first we realize that we have two circular cones with the same amount of liquid, meaning the liquid in each is the same volume. Volume of a cone is equal to 1/3 pi r squared times h. And then after that, a spherical marble of radius 1 is dropped into both, so they still have the same volume, but each one is added with 4/3 pi r cubed, and in this case, it'll be 4/3 pi because the radius is 1. Let's first look at the volume of each cone originally being equal. That is going to be, respectively, for each cone, 1/3 pi times 3 squared, given the height is h1 in this case and h2 in this case, h1, and 1/3 pi times 6 squared times h2. That simplifies a bit to become 3 pi h sub 1, and this is equal to 12 pi h sub 2. So this is how you would express the volume of each cone given any height, h1 and h2. After the ball is submerged, fully submerged, each cone will then rise by a height h1 prime and a height h2 prime respectively. And that means the new volumes will then just be 3 pi h sub 1 plus h sub 1 prime and 12 pi h sub 2 plus h sub 2 prime. And we know that this is achieved through adding the original volume to the volume of the sphere, and likewise for the second cone as well. So we can write two equalities. That gives us 3 pi h sub 1 plus 4/3 pi is equal to this expression here, as well as our second expression will then just be 12 pi h sub 2 plus 4/3 pi is equal to our second expression. Okay, let's see if we can find any other relationships. We first realize that since these two volumes of the original two cones is going to be equal, we know 3 pi h sub 1 equals 12 pi h sub 2. This gives us that h sub 1 equals 4 h sub 2. So if we do some calculations on these bottom two equations, we can first cancel out a pi, and then move the 3 to the left-hand side, giving us 3h sub 1 plus 4/3 over 3 is equal to h sub 1 plus h sub 1 prime. And then the second equation is canceling out the pi, gives us h sub 2 plus h sub 2 prime equals 12 h sub 2 plus 4/3 over 12. And then we notice this can be rewritten as being equal to h sub 1 plus 4/9 equals h sub 1 plus h sub 1 prime, and h sub 2 plus h sub 2 prime equals h sub 2 plus 4 over 36, which is just 1/9. This is equal to h sub 2 plus 1. And then we notice we can cancel some stuff from both sides for both equations, the h sub 1s and the h sub 2s. And then we're ultimately left with h sub 1 prime equals 4/9 and h sub 2 prime equals 1/9. So therefore, since we're asked to find the ratio of the rise in liquid level in the narrow to the rise in the wide, that would be h sub 1 prime over h sub 2 prime, which is equal to 4/9 to 1/9. And that gives us 4 to 1, which is answer choice E.